Hello, I am Abhirup Barua. I am from Jadavpur University and I will be covering the chemical bonding chapter in the subject Neat Chemistry. So the first topic that I am going to cover is Lewis dot structure. What is the Lewis dot structure? The first question that may arise in your mind. So a Lewis dot structure is nothing but a diagram that helps you to understand the bonding between two atoms in a molecule as well as a lone pair of an atom in a molecule. And it was developed by Gilbert and Lewis. So it was developed by Gilbert and Lewis, and this method uses dots to symbolize the valence electrons. This is a very important point. This structure helps us to understand the arrangement of atom and distribution of electron in a molecule. Now you must be wondering, what is a basic principle of a Lewis dot structure? Means, how can we draw a Lewis dot structure? What is the basic fundamental requirements or method that we can apply to draw a Lewis dot structure? The first thing that we should know about Lewis dot structure is octet rule. So first we will basically discuss what is an octet rule and how it is important for drawing a Lewis dot structure. So we can see the basic principle of Lewis dot structure. The first one is the valence shell electrons. The outermost electrons of an atoms are called valence shell electron. Suppose we have sodium. So sodium has electronic configuration of 281. So in the outermost shell there is one electron in for sodium molecule atom, and this these valence shell electrons play a crucial role in chemical bonding because these are the electrons that participate in the bonding. And the next key point about the basic principle of Lewis dot structure is octet rule. We will discuss it in detail now. We know that all the atoms of periodic tables of elements want to achieve stability, and to achieve stability the basic fundamental rule is that every atom should have 8 electrons in their outermost shell. This is how they achieve stability. So if we go to the slide and see that most atoms try to achieve a stable electronic configuration resembling noble gas. So noble gas, for example neon, the neon, xenon, all these noble gas has 8 electron in their valence shell. These are called inert gas. These are the most stable elements in the periodic table. All the other elements in the periodic table want to achieve this stability, and for in this process the elements lose or gain electrons and formulate bonds. So the atoms strive to achieve a stable electronic configuration resembling noble gas, which have a full outer shell of electron. Usually it is 8 electrons. There is an exception, we will discuss it later. And the octet rule suggests that the atom tend to gain, lose or share electron to achieve this stable configuration that we have discussed earlier. So there is an exception of hydrogen and helium in octet rule. The exception is that hydrogen follows the duet rule. So hydrogen will need two electrons in their outermost shell to achieve stability. And helium is an exception to octet rule because it is the only element in the periodic table which is stable with only two electrons. This is an important point for exam point of view. Now we will look at one structure of nitrogen molecule, N2. So we know the configuration of nitrogen, the electronic configuration of nitrogen. The electronic configuration of nitrogen tells that the outermost shell has 5 electrons. So now if we look at the diagram, you can clearly say this nitrogen atom has 5 electrons in the outermost shell, and this nitrogen also has 5 electrons in outermost shell. Now 3 electrons from nitrogen will form a bond between them. Here we can see that N2 molecule is being formed and 2 electrons or one lone pair is left out in the each electron, resulting in formation of N2 molecule where there is one bond which is known as pi bond and the other two are known as sigma bond, and there are 2 lone pairs. This is how N2 molecule is being formed. Now if we check the octet rule, is octet rule satisfied in N2 molecule? Yes, because if we look at the left nitrogen molecule, there is 8 electrons in the outermost shell now by sharing with other nitrogen molecule. Similarly with the right hand side nitrogen, there is 8 electrons. You can see that clearly here. So the octet rule is satisfied, and the Lewis dot structure is basically, this is the basic description of how we achieved this diagram. So I am not going into the details of it because it is the same thing. You can check that out. Now moving forward, we will be covering different type of chemical bonding. Now the first question you must be asking to yourself is, what is bonding? Bonding is nothing but the attractive force between the two atoms of a molecule which results in a strong bond or weak bond. We can divide chemical bonding into majorly 2 categories: strong bond and weak bond. In this lecture we will discuss 5 type of bond, 4 strong bonds and 1 weak bond. The 4 strong bonds that we will be discussing are ionic bonding, chemical bonding, coordinate bonding, metallic bonding, which come under strong bond, and we will be discussing hydrogen bond under weak bond. So the first type of bonding is ionic bonding. Now what is an ionic bond? Ionic bonding is nothing but a complete transfer of electron from one atom of an element to the other atom of an element, formulating ions. In this process, one cation and one anion, opposite charge positive and negative ions respectively, are formed. The ions plus and minus are together tied using electrostatic force. Now if we look into the slide, then we can see that an ionic bond is type of chemical bond that occurs between two atoms when there is a significant difference between electronegativity. Very important point, because there is a complete transfer of electron, so it is very obvious that one electronegative element will will want to transfer will want to get one electron from a non-electronegative atom, resulting in the complete transfer of electron from one atom to another. Very important point. This transfer leads to formation of ions I mentioned above, the charged particles, and one atom loses electron and become positively charged known as cation, and other gain electrons to become negatively charged anions. The electrostatic attraction between these oppositely charged ions are called ionic bonds that I have mentioned below. This term electrostatic attraction is very important for exam point of view. If we look at the example of sodium chloride, now chlorine is electronegative element, we all know that. Sodium wants to lose one electron in the outermost shell to achieve 8 electrons in their outermost shell. So now if we look, this is the outermost electron of the sodium, and chlorine will take this electron and it will now have 8 electrons in their outermost shell, having a same configuration like inert gas. Now the sodium has 8 electrons in their outermost shell, chlorine also has 8 electrons in their outermost shell. Now sodium loses 1 electron, so it becomes Na plus, which is an cation, and chlorine accepts 1 electron. The complete transfer of electron causes this, and it becomes Cl minus, and the ionic bond is formed by this. Now next type of bonding is covalent bonding. This type of chemical bonding is formed when two atoms share electron between themselves. This kind of bonding is very special because these are the only bonds that binds the two atoms in a molecule. These are the stable molecules, and after formation of these bonds highly break. The example of covalent bonding can be methane, or we can say hydrogen atom. If we read slide, then we can see that a covalent bond is a type of bond that forms when two atoms share electrons. Unlike ionic bonds where electrons are transferred, very important point, one atom to another, covalent bonds involve in the mutual sharing of electrons between atoms to achieve a more stable configuration. The octet rule is still followed here, and we have seen the example nitrogen. If we go back to nitrogen, yes, this is an example of nitrogen molecule. This is the example of covalent bonding where 3 electrons share themselves with the other nitrogen molecule, resulting in 3 covalent bonds and fulfilling the octet rule of having 8 electrons in the outermost shell. Now, if we look at hydrogen, which is an exception of octet rule, it follows duet rule, but it forms hydrogen forms covalent bond. Hydrogen has 1 electron in the outermost shell, and this uh, this uh, this electron in the outermost shell uh, forms a covalent bond using uh, using a this forms a covalent bond using the outermost shell and forms the basic H2 bond. If we look that each hydrogen atom has 1 electron in their outermost shell, through the formation of covalent bond, the hydrogen atom share their electron to achieve a stable configuration. This is very important because this follows octet rule. This does not follow octet rule. This follows duet rule, which is an exception. And H2 has a single covalent bond between two hydrogen atoms, and each hydrogen atom has now a full outer shell of 2 electrons. Now the next type of bonding is coordinate bonding. Coordinate bonding is nothing but a complete transfer of lone pair from one atom of a molecule to the other atom of a molecule. For example, if we look at SO2 molecule, we know that sulfur has 6 electrons in the valence shell, and after forming one sigma bond and one pi bond with one oxygen, there will be uh, uh, 4 electrons left in the outermost shell of sulfur. Now, after that, the sulfur will transfer one lone pair of its available lone pair to the other oxygen with and this is how we form coordinate bonding. The example of coordinate bonding can be easily seen in transitional elements. An example of coordinate bonding is NH4. Now we will look into the slide. Coordinate bond is also known as a dative bond or coordinate covalent bond. This is the type of covalent bond which both electrons are involved in the bond come from the same atom. There are two types I have mentioned earlier, that one atom will donate and one atom will accept. In the case of SO2, the sulfur atom is the donor atom and the oxygen atom is the acceptor atom. So now we can see, yes, here it is, the one atom donates both electron to be shared with another atom, creating a shared pair shell. The atom providing the electron pair is called donor, and the atom receiving the electron is called the acceptor. If we look into the NH4 plus example, then we can see that in ammonium NH4 plus ammonium ion, the nitrogen donates a lone pair of electron to a proton H plus, forming a coordinate bond, resulting in NH4 plus. We know nitrogen has 5 electrons in their outermost shell. 3 electrons of are involved with the side atom hydrogen, so there are 3 atoms involved. So now there is 2 atoms left. There are 2 atoms left. 2 electrons left. These 2 electrons are transferred from nitrogen to hydrogen. Hydrogen proton basically H plus, and forming NH4 plus ion with a coordinate bond. Now next is hydrogen bond. Hydrogen bond is nothing but a bond of a hydrogen molecule with respect to its electronegative partners. Now a hydrogen bond is a strong dipole-dipole interaction between a hydrogen atom covalently bonded with a highly electronegative atom such as oxygen, nitrogen or fluorine. Or the electronegative atom can be of a separate molecule also. An example of hydrogen bonding is between water molecules, where the hydrogen of one water molecule is attracted to oxygen of a naught. Metallic bonding. A metallic bond is a typical chemical bond found between the metal atoms in a metal lattice. In metallic bonding, electrons are delocalized and moved freely in among the positively charged metal ion, creating a sea of electrons that holds the metal ions together. An example in the metallic bonding in solid metals like copper, where copper atoms share their electrons in a collective electron cloud. Now we will discuss the valence shell electron pair repulsion theory, which is a model used to predict the shape of the molecules using the repulsions of electron pairs in the valence shell of atoms. Earlier in the octave 12, we could not predict shape, but here using this theory we can predict shapes of molecule also. Now there are some terms we need to learn before going into predicting the structures. The first is bond pair. Bond pairs are nothing but the, um, the electrons involved in the covalent bonds are known as bond pair. These are the shared electrons between two atoms. Lone pairs are the non-bonding electrons in the valence shell. Here you can see that the lone pairs are the non-bonding electron pairs that reside on an atom that do not involve in the covalent bonding. So in the NH3 molecule, the three electrons are involved of nitrogen in covalent bonding, and there is three bond pair with the side hydrogen atom and one lone pair because two electrons are left and are not used in bonding. Type of repulsion. There can be three type of repulsion in uh, in this VSPR theory. We can say that there are three type of repulsion. The first type of repulsion is lone pair repulsion, and the second one is lone pair bond pair repulsion, and the third one is bond pair repulsion. We need to know the fact that lone pair repulsion is the highest, which causes the deformation of the basic structure of the molecule. There is important point which I am going to mention right now, that why lone pair has the highest repulsion. So if you look at the slide that I have mentioned, that the electrons in a lone pairs are that are not involved in bonding are free, so the repulsion is higher. Because of one free electron, the repulsion between a lone pair and bond pair is somewhat higher than that of a bond pair and a bond pair. So we can see very easily that the lone pair repulsion is greater than the lone pair bond pair repulsion, and which is greater than bond pair repulsion. Now the next question is, what is steric number? So if we understand the concept of lone pair and bond pair very well, and now we can predict shape using the steric number. What is a steric number? Steric number is nothing fancy but the summation of the number of lone pair plus number of bond pair. Here we can see the steric number is number of bond pair plus number of lone pair. Now we will see an example. In the water molecule, the central atom oxygen has two lone pair and two bond pair. Okay, and thus the steric number is 4. Now there is a chart which predicts the shape of a steric number 4 molecule. The other example is methane CH4. The central atom has 4 carbon. Central atom has 4 bond with hydrogen atom, and resulting in 4 bond pair and 0 lone pair. This has a different structure than water, although both have same steric number, because there is a difference in lone pair and bond pair. Now we will discuss what is the effect of the molecular geometry because of this. Now we can see the arrangement of bond pair and lone pair can influence the basic structure of a molecule, which can result into the various molecular geometry that we have discovered. And these some examples are the tetrahedral geometry, the trigonal planar geometry, the bend geometry. VSEPR theory helps explain and predict the shape of molecule by minimizing the repulsion between the electron pairs. So, in this theory, the lone pairs will be basically put in such an angle that the repulsion will be minimal. Now we will discuss all the geometry one by one. If we get steric number 2 and there is only two side atom, that means that shape is linear, and the angle between the side atom and central atom bond, or the two bond pair, is 180 degree. If we have three side atom and no lone pair, this three bond pair, zero lone pair, then it will form a trigonal planar shape where the bond pair angle is 120 degree. If there is one lone pair, because of repulsion, the angle will be less than 120 and the shape will be angular or bent. Here is the trigonal planar and bent or angular. These geometries are very important to remember beforehand, because in example we will be given a molecule and asked to predict its shape. So we need to know this chart very well. So now, if the steric number 4 that we have discussed earlier about water and methane, if there is no lone pair, zero lone pair, four bond pairs, then the shape is tetrahedral and the angle suitable is 109 degree. If there is one lone pair, then it is called as trigonal pyramidal. If there is two lone pairs and two bond pairs, then it is called bent or angular. So here it is, steric number 4 I have covered. If the steric number is 5 and there is 5 bond pairs and 0 lone pairs, then this is called trigonal bipyramidal. Here the angle is 90 degree between the equatorial and the axial atoms and bonds. If there is one, so here is an important point, if there is one lone pair in steric number 5, then there is 4 bond pairs, 1 lone pair. Ideally, the lone pair should be placed in equatorial position, because that's how we can achieve minimum repulsion. And the goal of this VSEPR theory is to predict the accurate shape and describe the reasons behind it. And after predicting the shape, we have to also ensure that the atoms of a molecule are stable. So you can see that this is a seesaw type, and if there is two lone pairs and 3 bond pairs, then it is called T-shaped. And if there is 3 lone pairs and 2 bond pairs, then it is linear, and all the 3 lone pair will be placed in the equatorial position. Very important point. So if the steric number is 5, then the types are trigonal bipyramidal, seesaw, T-shaped or linear. If the steric number is 6, then 6 bond pairs, 0 lone pair. Now you must be familiar The shape is known as octahedral. One lone pair, 5 bond pair, square pyramidal. The angle is now less than 90. If there is two lone pair and 4 bond pairs, then it is known as square planar. 3 lone pairs, all of the lone pairs will be in equatorial position, giving a T shape. And if there is 4 lone pair and 2 bond pair, resulting in linear shape. So these structures you should remember very well to predict the shape of a given molecule in an exam. Now we will use the VSEPR theory to predict shapes of two molecules H2O and NH3. Firstly, we will identify what is the central atom. For H2, the central atom is oxygen. If we look at the oxygen and now place the two side atoms hydrogen and formulate 1 bond each, resulting in 2 bond pairs and 2 lone pairs. And if we look closely, the structure is AB2E2. And if we go to the summation of bond pair and lone pair, we can say the summation of bond pair and lone pair is 2 plus 2, which is, sorry, I will write only 4. And if we go to the chart and look at the steric number 4, and in the steric number 4, 2 bond pairs and 2 lone pairs, we can clearly see that it is a type bent. So now we can draw the water molecule using the bent or angular molecule structure. Next is ammonia. If we look, the nitrogen has 5 electrons in the outermost shell. 3 electrons form covalent bond with the side atom hydrogen, forming 3 bond pairs. Now 2 electrons left will be having now 1 lone pair. So now 3 bond pairs plus 1 lone pair, resulting in steric number 4. So now both have a steric number 4, but although both have steric number 4, because of the number of lone pairs, they have different structure. Now we will go back into the chart and see what is the type. If we go at the steric number 4 and check what is the 3 bond pair and lone pair, here is the 1 lone pair. We can see in the top in the column that 1 lone pair, steric number 4. So basically the shape is trigonal pyramidal. So the ammonia has trigonal pyramidal shape now. Yes, you can see that ammonia has a trigonal pyramidal shape. Water has bent shape that I have mentioned earlier. So now this is a brief introduction about the chemical bond chapter. I hope you liked it. Please like. Thank you.